Hello there. In this video we're going to be doing some converting back and forth between degrees and radians, and for that we need to remember the rule. 360 degrees is equal to 2 pi radians. You could also do 180 degrees is equal to pi radians. And the rest of these problems we can actually set up with dimensional analysis. So this 150, I'll write a 150 over 1. I want the degrees to cancel out, so I'm going to put the 360 degrees on the bottom and the 2 pi radians on top. That way it'll be counting in radians when I'm done. So let's see here. We're going to get the zeros to cancel out, and 15 and 36 are both divisible by 3. So we'll get a 5 here and a 12 here. The 2 can cancel with the 12 there, leaving a 6 on the bottom. So we're going to be left with 5 pi over 6 radians. And like some of these, at some point we want to kind of know where they are too. And you can think graphically. 150 degrees is going to be over here. Oh, I recognize that there's a 30, 60, 90 triangle that's involved there. And then you could split this up into like 6 equal parts, and you've gone 1, 2, 3, 4, 5 of them. So 5, 6 pi. At this marker over here, that's the pi, and this one over here, that's the 2 pi. But that can be a faster way to do it, but if the numbers are a little bit stranger, this one we could probably do that on, then you'll want to do this conversion. So actually, let's do that with the 225. 225, I happen to know that that is 45 degrees past the 180. So what this is chopping into is we have 4 equal segments there for each 45, and I have gone a total of 5 of them. So that must be 5/4 pi radians. And the fraction work should give me the same thing. And it does. So with numbers like 288, I know that there's not going to be a 30, 60, 90 or 45, 45, 90 triangle involved with them. The 88 kind of spoils that. So I'm not familiar with just how many fractions of the circle it's going to split it up into. It's not going to be thirds or fourths or sixths. So we'll do this one with the unit conversion. Okay, so what options do we have here? Half of that, that's 180 going to be down there. There's 144 up here. Half of that, there's 72 there and 90 there. We could go half of that, 36 there and 45 there. And both of those are divisible by 9, so that's going to be a 4 on top and a 5 on bottom. So at the end of this whole thing, it looks like we're gaining 8/5 pi radians. I apologize for going all over the place with these. 48 on the bottom, 360 degrees is 2 pi radians. Again, both of these are even, so I could actually cancel the evens that way. I could get it down to 180. 48 and 180, both are divisible by number of things. Both are divisible by 6, so that's going to be 8 on top, and that divided by 6 is, what, 30 on the bottom? Those are both even, so that's a 4. There's 15, so I got 4 pi over 15 radians, or 4/15 pi radians. Box all those radians there. Now there is a way to kind of double check this. You could set your calculator to degrees, type in this number, see what the sine ratio is, set your calculator to radians, do sine of this number here, check to see that it has the same ratio. That doesn't guarantee that it's right, but it's probably going to be right. You could also test cosines and tangents, converting between degrees and radians. Okay, going backwards, now I have stuff in radians, I want it in degrees. Write this first one as a fraction, 2 pi over 3. It'll if I do it as 2 pi over 3 over 1, it's going to make it kind of convoluted. The degree are radians in the top, so I'm going to have 2 pi radians in the bottom, and 360 degrees here. So what's happening is that those 2 pi's are canceling out. That 3 cancels with the 360, leaving me 120. So that is 120 degrees. Now you could also, this one is again one of those that you could think about graphically. Here's a circle, and I'm going forward 2/3 pi. So over here this is pi, remember this is 2 pi, and I'm going over 2/3 of the way to this point. So like there's a third, there's a third, that's a third, that's a third, that's a third, and I've gone 2 of them, so I've gone this distance there. Well, that's got to be 120 degrees. I could think graphically about this one too, 7/4 pi. So there's a fourth, there's a fourth, 1, 2, 3, 4. That's 4/4 to get us up to pi. 5/4, 6/4, 7/4, right over there. So that is going to be 45 degrees past the 270, or 315 degrees. I think you're going to want to do them this way as much as you can. 5/12 pi. I could probably do the same thing. I'm going to do it this way. I'm going to use the unit conversion 180 over pi. Keeps the numbers a little bit smaller. Pi's are going to cancel. 12 and 180. Is 180 divisible by 12? I can't remember. Both are divisible by 2, so that's going to get me 6 and 90. And those are both divisible by 3, so that'll get me 2 and 30. So what do we have here? Oh, and 30 is divisible by 2, that gets me 15. So that cancels out completely. I got 5 times 15, that's 75 degrees. Alright, last one over here, 16/9 pi. Now 1 pi is 180 degrees. We can cancel pi's out. 180 is divisible by 9, so that will leave me with 20. And now I got 16 times 20. Well, 16 times 10 is 160. Then I'm going to have to double that, so it looks like we're doing 320 degrees. Thanks for watching. Curriculum Scholarship for Life.